Hi, welcome to Sprint 17 of Dogen. This release was quite an important release for us. Part of it was the finishing of the meta-modeling exercise, at least as far as the JSON files are concerned, because it's important for us to really to test that the approach really works, and every time we add new meta-model elements, it kind of demonstrates the framework can cope and can be extended to other use cases that we didn't really envision when we started creating a meta model. So it's really good to see that a couple of things went into the meta model and the system kind of more or less worked as expected. We still have a number of things that need to be moved into the meta model, but at least everything that was under the data directory is more or less now what it should be. But one of the things that took quite a long time in this sprint was actually the MASD versus Dogen separation. And up to quite recently, I've been more or less carelessly using the terms MASD and Dogen almost in an equivalent way. And that resulted in a number of elements that were placed in the wrong sort of namespace, so to speak. For example, we are putting some of the Dogen profiles into the MASD namespace, which gives the impression to the end users that those profiles are available for everyone to consume. We also had a number of elements that should really be in MASD, but were under Dogen, so it was a bit confusing. So I went through the whole code base. We removed the containing MASD namespace for Dogen, just to make sure that nothing gets placed into the MASD namespace by mistake. And everything else that should have been under MASD, well, as far as we could see, I'm sure there will be fallout of things that still need to be done. But a number of things got moved, hopefully most of it. So the first breaking change you're probably going to notice when you get the latest version of Dogen is that the binary is no longer called mas.dogen.cli. It's actually just called dogen.cli. So this is one of the consequences of this rename. So you can see here we have version 17 of our Dogen. And as usual, we are using our Sprint 13 heavily modified simple example. What I'll do is I'm going to just quickly run through the features that don't really require changes to our test model. I'll just rattle through these, and then we will cover the last couple of features which are actually require a bit more demoing. So the first feature we mentioned in the release notes was that feature templates are now meta model elements. So what I'll show you what I mean by this is, if I take something like the variability, it's actually the Dogen, the variability model. I'll just make the model slightly smaller so you can see more model elements just for a second. Perhaps even more. So you see this model had a number of elements, regular elements, as well as a number of transforms. And now what we've done is we've added another set of entities that go into this model, which are our features. And features basically is something you are quite familiar with already. Every time you are toggling some of these key value pairs you see on the top level namespace, that's in effect a feature. In the past we had to declare these features using JSON, and then we would manually implement whatever was required. We would manually declare them in JSON, and then we manually implement whatever is required to read these features from the configuration data. With this change, we've done the first bit of the work, which is basically we no longer need to declare these in JSON. We declare them together with the model that is consuming the features, and then the code generator goes away and generates all the code required to handle this feature. So for example, in this particular case, we're using a type of text. The code generator knows that it needs to create a feature template of type text with a name, MASD variability profile, and so forth. So every time you add a new feature, you just need to add a model element with the right stereotype, and the code generator will generate the code to validate that feature and to bring it in to the meta model. As well as that, we also created an initializer, which is a pattern, a structural pattern we're going to use in the future. The initializer is responsible for finding all the features that are available in this model, and it creates an instance of all these features and pumps them into a registrar of features, so that Dogen is aware of all the features that are available. This also opens up the door for a very important thing that a feature that we wanted to put in Dogen for a while, which is documentation. So soon, hopefully in Sprint 18, it'll be possible for you to do -- help features or something of the kind, and it will give you a list of all the features and what they do, so you don't have to guess anymore what's available, which is a bit of a problem at present. I'm not actually going to demonstrate the generation of features because this is only used internally by the code generator, so I think it's not worthwhile doing that. Similarly, mappings as meta-model elements. In the past we had a JSON file that declared LAM entries, if you could call them, and then those LAM entries it mapped to a to a model element. So, for example, it would map something like integer to int, and string to string, and in C# to system.string, and so forth. The problem was this mapping was completely outside of the existing framework. So because it wasn't part of the meta model, we couldn't do the regular validation for the existence of types and so forth as we do at present. So what we've done now is we created two types of mappables, extensible and fixed mappables. For LAM, the language agnostic model, we're using extensible mappable, and these names are not exactly ideal, but they will have to do for now. And then we declared the whole of LAM, all the types that exist in LAM. We declared them inside of this model called MASD.lam, and you can see it's MASD, not Dogen. And then we pushed the responsibility, as explained in the release notes, of all the models to then map against the LAM model. So, for example, stud will have a number of mappings over to these types, and so the C# system model and so forth. Similarly, we also declared the variability types. So if you go back to the first feature that I mentioned, you can see we're referring here to a type called MASD variability text. In the past, this was hard-coded in the code base. Now we declared the variability model, and we did a mapping of that type. But in this case, is actually fixed mapping, because you can't extend it. It's actually just whatever it is in this model, and it's really only designed to do this. And this allows us to now not hard code the way that we handled mappings in the past. And it allows visibility to the meta model of how the mappings are taking place. Finally, the last two features are actually worth demoing properly. They are the new facet, which is lexical cast, which I'll show in a second, and also a bug fix. We had a bug on Sprint 16, sorry, where you couldn't put profiles at the model level. So what I'll do is I'll quickly demonstrate. I'll go back to the model that we used in the past. It's slightly modified, as you can see. So I've added a new entry, a new element to this model called an enum. As you can see here is a MASD enumeration. I kept the structure of the profiles that we had in the past, which was in itself a copy of the Dogen profiles. So it's fairly straightforward. But the key thing here really is not so much the profiles, but the top level profile, or not so much those profiles, but the top level profile I added. So I created a profile called castable, profile template. And what you can see here is that the feature that this profile refers to is this lexical cast, the new facet that I was speaking about. And for now, we set it enable to false. So I'll just demonstrate very quickly what happens before this feature. So if I just go to a cling shell, the usual cling shell, what I'll do is I'm just going to reset cling, because as you're probably aware, cling starts remembering states and then gets a bit confused. So I'm just going to first add the include directories, then add our binary, so. And then we will start by not having the lexical cast facet, and we'll see what that does. Notice though that we have the IO facet, so there is a level of conversion going on here. So we put this through our cling, and then if I then call func4, so what you see here is outputting my enumeration, ME, without using any kinds of casting, results in the IO facet being expressed, and that basically is a JSON dump of the type, as we are familiar with. And similarly, if I attempt to do a lexical cast into a string, because we defined the operator inserter, the inserter operator, C++ knows how to convert a string based on the inserter operator, so therefore we have exactly the same behavior. However, this may not be what we're looking for. We may actually want to just output a string and do a conversion of a string. In which case, it makes sense to just use lexical cast. So what I'll do now is, let's just try first to just Cling is not happy. So I'll do is I'll close Cling, and sadly Cling is a little bit sensitive, so I find that a lot of times it's just easy to restart Cling rather than try to understand what went wrong. For good measure, I will comment out IO, not that you need to, but actually, in order to comment out IO, I need to also comment out the string output over there. Okay, so what we'll do is restart Cling again. And we will not comment out IO. All goes according to plan, and the demo gods are with us. It should work. Okay, now if I call func4. Okay, so the reason why this is happening, of course, is because the operator is taking precedence over the lexical cast. So I was trying to be lazy here, but I don't think we can get away with it. So what we'll do instead is we will just do it properly, comment it out IO, comment out the IO we're doing here, restart Cling, and load all of our inputs, load our binary, and hopefully now what we should see is Cling slightly less unhappy. I know exactly what the problem is. Apologies. The reason why we're having this problem is because we haven't yet generated the lexical cast code. So it's a good spot by the compiler. What we'll do is we'll save now our model with this change. We'll just hop over to our shell, and in our shell we will just use Dogen to regenerate the model. And then if we just have a quick look at Git, yes, now you can see over here in Git a new file has got generated. So really what Cling was trying to tell us is that that file didn't exist, which is really what we'd expect. So now what we'll try to do instead is let's just try to do this properly really. Of course it helps if you restart Cling. So we restart Cling, and we will load the usual suspects. Now, because I'm being brave, I will insert both at the same time, because in theory this should work. And the specialization of template function should take precedence, hopefully. If I call func, exactly what it was expected. So as you can see here, this first case we're using still the IO operation as expected, and that's because of course we are calling the inserter operator. However, lexical cast is being clever now. It's determining that there is actually a specialization of the lexical cast, and because of that specialization, it's actually taking precedence, and so therefore it's using the specialized version of the lexical cast. And of course we could now do a similar thing, which is we could now say const auto enum, no, not enum, but e0 for example, and we could say please cast over to my enum. Of course I need to spell correctly. Please cast over to my enum if we just did originally, hopefully if all goes according to plan, we should see the right results. So yet again I will restart cleaning. I'm quite sure you don't really need to restart cleaning this many times, but just to save us from a bit more obscure clean errors, we will do the safe thing. So hopefully, if everything goes according to plan, of course, the cost should have been, I suspect we should be able to clean this till it didn't happen. So let's just try restarting clean yet again. And hopefully if all goes according to plan, of course the cost is on a string to the enum, so that sounds a bit more sensible. What we'll do is try it yet again. This is already becoming a bit of a long demo, but it's probably worthwhile also seeing the potential problems it may hit. And you can see here the cast just occurred, and you can now see the output here as a string for E0. So invalid is being converted again. Of course, the only reason why we're generating invalid is because we've, by default, we toggled the generation of an invalid enum. Had we not toggled that, it would have started off at an enumerate and another. It's just the default generates an invalid enum. So I think this gives a very good demonstration of how you can use this new feature. It's very useful, and hopefully in the future we'll also add the from string so that you don't actually have to use lexical cast if you don't need to. So in terms of the next sprint, so we stopped halfway with this work on feature templates. We still need to implement the other side of the feature template, which is the reading of data from a configuration and the generation of a real C++ type. At present that's still being done manually, so that's going to be our first task for the next sprint. We also started but did not complete the moving of whale templates into the meta model. The idea here is that whale templates are really these logicless templates. They're really at present a Dogen specific thing. They shouldn't really be distributed with a binary, so we need to move that. And the more difficult task is going to be to move fabric into coding meta model. So if you recall, we had a number of types in each generation meta model, C++, C#, which were part of the meta model but not really implemented as other meta model types, by this notion of dynamic injection of types. And we don't really agree with that approach anymore. So we need to move these types into coding to become full-fledged meta model items. And that's all for this sprint. Thanks for watching.